Hello everyone and welcome back to the channel. This is the third video from Advanced RAG and Q&A series. In the previous two videos, first we saw how we can design SQL agents in order to interact with tabular databases and SQL databases. And in the second video of this series, we saw how we can use knowledge graph to chat and interact with graph databases. In this video, my goal is to design an intelligent SQL agent Q&A and RAG system that allows us to interact with multiple databases. And these are the main objectives of our system. So first, we are going to combine RAG and SQL agents and use them alongside each other to take advantage of both. We also want to work with multiple vector and SQL databases simultaneously in our system. Our system can automatically decide which technique and database to choose in order to answer our query and the user's question. And finally, I want to show you how we can design SQL agents in order to interact with large SQL databases. So as you know, in the first video, we just saw how we can design SQL agents in order to interact with tabular databases in general. But what if the SQL agent fails to give you the answer in case your database is large? So that is something that I want to address in this video, and I want to show you a technique that you can use to improve the performance of your system in case that is the case that you're dealing with. And beside these objectives, I also want to talk about the LLMs that you can use to design this system. As you know, I mainly use GPT models, but GPT models are not the only models that we can use for designing these type of systems. So in this video, I will also mention the alternatives that you can consider for designing agentic systems, and I will address both closed source and open source models. And finally, I will mention some of the scenarios where I would strongly recommend you to use RAG, and some of the scenarios that I would strongly recommend you not to use it, and for instance, use SQL agents instead. I'm bringing this up again because after the first two videos, I received a lot of questions about why did you suggest us not to use the RAG when we are dealing with tabular databases. So in today's video, I want to also explain that and clarify it once again. And this time, to make it more clear, I want to compare different use cases where I would recommend you to use RAG versus where I would recommend you to use SQL agents instead. And hopefully this time it will make things more clear for you. So these are the frameworks that I'm going to use for designing this system. We will use OpenAI and GPT models as the LLMs. Gradio is the library that we are going to use for the user interface. This is technically the same user interface that we have been using since day one from LLM 0 to 100 series. And I'm going to use that same user interface for this video as well. I will use LangChain, LangGraph, and Langsmith for designing our system and also monitoring our system. And again, just to do a quick recap, these are the key features of our system. So our system handles unstructured data with RAG and structured data with SQL agents. It also has a built-in web search, and it can use it whenever it's needed. It automatically chooses the best tool for each task. And by that, I mean it automatically chooses between RAG and SQL agents. And also it automatically chooses the right database based on the user's question. It is scalable for large databases. I will show you a method that you can apply and see if it can improve the system's performance in case you are dealing with large databases. And also it is easy to connect our system to multiple databases. This is a high-level overview of the system that we want to design in this video. In the next slides, I will also show you a more detailed schema, but for now, my goal is to just focus on the key aspects of our system. So as you can see, a user asks a question. That question is going to be passed to a primary agent. Our primary agent has access to multiple tools. And as I mentioned, it automatically chooses the right tool and the right database based on the user's question. We will add 2 RAG tools and 2 SQL agent tools to our system in this video. And each one of these tools can interact with a separate database. So each one of the RAG tools interacts with a separate vector database, and each one of the SQL agent tools interacts with a separate SQL database. I also added Tavily search tool. I added it for one main reason. I want to show you that there is no limit to our system. And in case you have other features or other tools in mind, you can easily integrate them into the system. You can also see that I'm using different GPT models here. I'm using GPT-4 Omni for the primary agent and also for RAG tools. But for SQL agent tools, I'm going to use GPT 3.5 Turbo. And the reason behind that is I tested GPT-4o Mini and GPT-4o in SQL agent tools. I saw in LangChain documentation that they are suggesting to switch between 3.5 Turbo to 4o Mini, but for some reasons, it doesn't work. So in case you switch to either of these two models, GPT-4o Mini or GPT-4o, it fails to give you the answer from the SQL agents. My guess is that there is something wrong with LangChain backend, and hopefully it will be fixed soon and quickly. However, as of right now that I'm recording this video, our best bet is to use GPT 3.5 Turbo. My main selection of these two models were based on the cost efficiency of the models. As you can see, GPT-4o Mini is the cheapest one. After that, if I want to choose, is GPT-4o and then GPT 3.5 Turbo. So these are my top three choices when it comes to cost efficiency. Then it's about the speed. GPT 3.5 Turbo is the fastest model that we can use. And finally, the capability of these models in handling these tasks. But of course, the final choice of these models should be based on your experimentations and testings. But for this tutorial, I'm going to stick to these models. And for the datasets, I'm going to use 4 datasets. I will use 2 PDF files and I will convert them to vector databases. One of them is Swiss airline policy, and the other one is the stories PDF. This is the one that I used in RAG GPT video as well. We have Swiss airline travel database as one of our SQL databases, and I will also use Chinook database. This is the database that I used in the first video of this series, but this time I'm going to treat it as our large SQL database. And on this database, I will show you how we can improve the agent's performance in case it cannot give us the answer because of the size of the database. Now it is time for a quick demo of our chatbot to see how it works. Let me ask a couple of questions and see how it can handle the questions. So the first one is, who is Lily? For this one, the chatbot should be able to choose the right RAG tool and the right vector database. Lily is a young bee who lives in a vibrant meadows of Blossom Valley. Let's verify the answer. So if I open the PDF file, you can see that this is the first line that our chatbot used in order to give us the answer, and the answer is correct. So let's ask another question, and this time from the second vector database. So I've already created the vector databases from these PDF files, but when we are going through the code, I will explain to you how it can be done. Based on the airline policy, do I need to reconfirm my flight? No, you do not need to do that. Let's see if, again, that is the right answer. Again, if you check the PDF file, you will see, do I need to reconfirm my flight is the second question in the PDF file, and the answer is no. And again, the chatbot was able to give us the correct answer. Let me ask a question, a simple question at this point, from one of our SQL databases. So at the end of this video, I will ask more challenging questions, and I will ask more complex questions from our chatbot to see how it performs. But for now, I just want to see if it can detect the right SQL database. So I just simply ask, what are the table names in the travel database? It gave me 11 table names. And if I go into my project in notebooks, in Explore databases, if I open travel database, you would see that there are 11 table names, and that is the correct answer as well. Also, if I open the terminal here, you can see all the steps that our chatbot went through to answer each one of the questions. For instance, for the last question, for the table names in the travel database, the chatbot chose query travel SQL database function, and then that function was executed in order to give us the answer. So the chatbot correctly detected the right tool and the right database for that question. And finally, let me ask a question that our chatbot needs to search the internet for it. Give me the link of Trump and Harris debate on YouTube. So there is no way that GPT model has access to that link from its training data because it just happened a few days ago. So let's see how our chatbot would do on that question. So let's check the result here. So the chatbot gave us 2 links, and the number of links that can be returned from Tavily search is something that we can choose. I've already set it to 2, but while we are going through the project, I will show you where and how to change it if you want. So let's open one of the links and see if the chatbot was able to pick the right tool and give us the right answer. So that link points to a YouTube video called Live Presidential Debate, Harris versus Trump, hosted by ABC News. Again, the chatbot was able to choose the right tool and give us the correct answer. So in the next step, I want to show you Langsmith, which is the tool that we want to use to monitor our system, and to be more specific, the agentic graph that we want to design in this project. As you can see, it has already been attached and connected to our project for a while, and I can already see all my chat history through this dashboard, and you have access to a lot of information here. But in this video, I'm not going to cover all the details and the features that Langsmith offers. Feel free to check it out. It also has a free tier, so in case you are just planning to test it or to use it for development purposes, you can use it for free. I've been using it for a while and I never paid for it. So let's quickly cover some of the key aspects and see what it offers. First, you can see that you have access to all your inputs, outputs, start time, latency, number of tokens that was used for that specific query, and the cost of that query. And if I open any of these queries, you can see that Langsmith automatically detects the agentic graph that I've designed for this project, and for each step of the agent, for each step that was executed in my agent, it can give you again all the information that we just saw. And if I open, for instance, one of the questions that we asked about, we asked from a vector database, you can see that you also have access to the retrieved content for that question. So you also have the ability to verify the performance of your chatbot, or in case the answer that the chatbot gives you for a specific question is wrong, you can see what is wrong with that question and why the chatbot is making the mistake. You can also see that it shows you the model, the start time, end time, whether that query and that process was successful, the total number of tokens, and a lot of information here. So there is one last metric that I want to talk about here, which is the thread ID. Thread ID allows you to manage and distinguish different chat sessions. So in case you want to have access to a specific user's chat history for a specific chat session, you can do it using thread ID. And in case you want to, for instance, give your users the ability to go back to their previous chat sessions and continue their chat sessions, again, you can do it using this metric. But as you can see, thread ID in this video is a constant. It is equal to 1. But in case you want to use this project for your applications, you need to modify this part and make sure that you assign a unique value to each one of your chat sessions. So that was it for the demo. Let's continue our presentation and start developing the project together. So in this slide, I want to briefly go through the scenarios where I'd recommend you to use RAG and the scenarios where I'd recommend you not to use it. I'm not going into the details, and I don't want to spend a lot of time on this because this is somehow a summary of what I've already discussed in my previous videos, but this is just for clarification and to just give you a better idea what I meant earlier. So I'd recommend you to use RAG when you want to deal with unstructured data. For instance, you want to interact and chat with PDF files, text files, markdown files. There is only one exception, and that is when you want to extract a meaningful graph out of your unstructured data. This is what I've already covered in the second video of this series, in the knowledge graph video, and I showed you a Microsoft project where they used knowledge graph in order to extract a graph out of unstructured text data. That is the only exception, but in general, when you want to interact with these type of datasets, RAG is your best choice. Next scenario is when querying a specific columns or a combination of columns in a tabular dataset. So this scenario was raised by one of the channel members. They have tabular datasets. In one column, they have questions, and in the second column, they have answers. So in this type of scenarios, I'd recommend you to merge these two columns together, create Q&A pairs, and then from these, let's say one column, which is a combination of Q&As, create a vector database, and then use a RAG pipeline to interact with it. This is something that I've covered in the second video of this series when I was talking about knowledge graph, but I mentioned it as a general strategy for this type of scenarios. Third is handling columns with names, descriptions, or other fields prone to typos. In case that is the scenario that you're dealing with, Then, depending on the questions that your system should be able to handle, you might want to have a RAG system as a backup. So in case the SQL agent fails to give you the answer, then the RAG pipeline can be executed and you can see if that can improve your system's performance or not. But it is very important to consider what questions your system should be able to answer. For instance, if your user wants to ask a question like, give me the mean value of that specific column in my dataset, well, then having a RAG pipeline as a backup is not going to help you at all. But in case they are just asking general questions about the content of your tabular dataset, well, having a RAG pipeline might be helpful. But keep it in mind, the type of the questions is the key consideration in this scenario. Finally, if I want to wrap up in one sentence, I'd say when semantic relationships in the data can help retrieve more accurate answers. So if you just understand this one sentence, you would easily understand when a RAG pipeline would be the better solution for you versus when it is better to avoid it. On the other side, when should I use SQL agents? First, let's go through all the key points here, and then I will explain what I mean exactly. For interacting with structured tabular databases, that is the first one. Or if you need to query your database in a precise, expert-like manner. And finally, if your query requires retrieving exact data, for instance, fetching all rows containing a specific piece of information. So at the end of the first video, I tried to clarify this point by comparing different questions that you can or you can't pass to a RAG pipeline. And also I showed that how SQL agents allow you to have more power over your databases. So this is what I mean here. For instance, in the second case, when I mentioned that you want to query your database in a precise and expert-like manner, it is exactly like the example that I gave you earlier. For instance, if your user wants to ask a question like, give me the mean value for that specific column of the dataset. Well, in that scenario, a RAG pipeline can never do that for you. It is not designed for those type of questions. But again, like this question right here, if you want to fetch all the rows containing a specific piece of information, these are the type of questions that RAG SQL agents and LLM agents are able to handle, while RAG pipeline fails to do so. So keep it in mind, the use case for these two strategies is very different, and you can compare the scenarios that I briefly mentioned here. But in general, the best scenario and the best strategy depends on your use cases, your objectives, the questions that your users want to ask from your system. And these are the things that you need to take into account before choosing the right approach. So these are just some general guidelines that I'm giving you. But as you saw here, you can even have RAG pipelines when interacting with tabular databases under certain circumstances. In this slide, I wanted to give you two key references that I'm going to use for designing today's project. First is the RAG GPT project, where I went into all the details of how to design a RAG pipeline from scratch. So our RAG tool is going to be somehow a simplified version of that project, but I will go through it quickly because I've already covered everything in that video, and I'm not going to just spend time to explain everything again. And on the other side, in Chat with your database using SQL agents video, I've already covered all the details and steps that are necessary for designing a SQL agent. We used LangChain to design this agent right here. I'm going to use the same agent, at least for one of our databases, and I will apply some changes and modify it a little bit to interact with the large database. So for the second agent, I will go through the details, but for the first one, again, I will cover it very quickly, and I will use the same agent that we designed in that video together. Beside these aspects, I will also avoid going into the details for how to prepare a vector database and how to prepare your SQL database, because again, these are the topics that I've covered in my previous videos. And one last thing is the design of the Gradio user interface. Our user interface is going to be the same UI that I've been using in all my previous videos. So I will just show you the code, and I will not go into the details of how we are going to design the UI together in this video. This is technically the same UI that I've been using. I just copy pasted it from my previous projects, and I'm going to use it here as well. This is the project schema that I mentioned to you earlier. And at the top, you can also see the overview just for comparison. But on the bottom, I try to show you all the steps that happen in each one of our tools. And then while we are going through the code, we implement everything together. So on the RAG tool side, user's question is passed to an embedding model. Then we perform a vector search using the embeddings on a vector database. Then the search result, which we are calling it the retrieved content, will be passed to a large language model along with the user's question, the chat history, and the system role in order to generate the final answer for the user. On the SQL agent side, the user's question is passed to a large language model. That LLM generates the SQL query that corresponds to the user's question, and then we run that query on the database. We get the results and we pass it to our large language model. And again, we pass it alongside the user's question, the chat history, and the system role in order to generate the final answer. And on the Tavily search side, we pass the user's question to Tavily search using API call, and then we will just get the search results and we pass it to a large language model, again alongside with the user's question to generate the final answer. And here I also try to show you what data sets you can use to interact with each one of our tools. For creating the vector database, you can create it from all your unstructured data sets, for instance, PDF files, text, Word, Markdown file, etc. For the SQL database, you can create it from your tabular data sets, from CSV files, Excel files, SQL database, and in general, any tabular database that you want. And the Tavily search is not going to have access to any database. And as you know, it performs a web search and it just sends us back the result from the web search. In this slide, I want to go through the models that we can use for designing this system, because one of the questions that I get a lot after each video is, can I use that model, or can I use open source models specifically, is one of the main questions that I usually get. So yes, the answer is you can use both closed source and open source models. And I'm talking specifically about LangChain here because this is the framework that I'm going to use to design our system today. So I personally will use OpenAI and GPT models for designing our system. You can use Anthropic, you can use AWS models, Google Cloud models, or you can use models from Hugging Face or using Ollama framework. These are the commands that you can use in order to call the models. And these are the references where LangChain explained how you can call the model that you want and integrate it into these type of systems. And on the right side, I also just briefly mentioned which one is free and which one you have to pay for it. This is the most important slide for designing our project today. And here I try to summarize all the information that we need to have in order to be able to design our project. First, I want to explain what do we mean by an LLM agent. An LLM agent is a large language model that has access to multiple functions. And depending on the user's question, that model may or may not call one of the functions that it has access to. And I'm going to show you how we can create an LLM agent from scratch, both a custom agent and also an LLM agent using LangChain. And I will also show you how we can add tools to our large language model, because we cannot just simply, for instance, design Python functions and pass it to a large language model. So these are the steps that we need to go through, and I will show you everything in a notebook soon. For instance, I'm going to use Python today. In Python, I will write functions. These are our tools. And then in order to be able to pass those functions to a large language model, I need to convert them into a JSON format. And then we can pass those converted functions to a GPT model, for instance. And when a user asks a question, that GPT model may or may not call one of the functions. So that GPT model can decide whether to answer the question using its own knowledge or to call one of the functions. In case it calls a function, the output is again in JSON format. So what I need to do is to convert that JSON format to a Python function so I can execute it in my environment, which is going to be Python in our case. So I will show you in a moment how we can do it again from scratch and using LangChain. And finally, after we have our model and our tools, it's time for going through all the steps in order to design the graph. So we need to initialize the graph from with the state, define the graph nodes, define the entry point and graph edges, compile the graph, and then it is ready to be used in our chatbot. So I'm going to also keep each corresponding part of this slide on the top corner of the screen, so you can follow all the steps, both using this schema and also checking the code while we are going through them. And now it's time for going through the code. Let's begin and see the project first, and then let's start developing the project together. This is the LangGraph webpage from which I took that step-by-step breakdown of how to design a graph. So feel free to come and check this webpage. They also have an example for you on the top. And if you open each one of these steps, they have further explanations, which I didn't go through them because I want to show them to you while we are going through the code. And you already have access to the project. So if you come into my GitHub repository, you can go into Advanced Q&A and RAG series. And then we have 3 projects here. You can see Agent Graph, Intelligent Q&A, and RAG System. And if you go into that project, you can see the project is already uploaded for you, and you have access to the README file, and it explains all the steps that are necessary for you to execute that project, from cloning the repository, preparing an environment, and how you can execute the project itself. So now let me go through the project structure. I kept it consistent. So if you have watched my previous videos, this is almost identical to the previous videos. Of course, it has some small adjustments, but the general structure is the same. We have the configs folder that contains our config files. We have the data folder that contains both the raw data and our vector databases, SQL databases, etc. We have an image folder that contains a few images for our user interface and the README file. We have the memory folder, so our system also has a built-in memory in place besides Langsmith and LangChain's state, which I will explain later. I added a memory in place. I wanted to keep track of my chat history and save it locally, and at the end I decided to keep it there. So having this memory alongside Langsmith doesn't really make sense. And in case you want to keep Langsmith, you can remove this memory from the system, and in case you want to design your custom dashboards, you can expand on it and you can develop your dashboard as well. We have the notebooks folder. This is where we are going to go through all the knowledge and everything that we saw in the slide together. This is the source folder that holds the project itself. So after we went through all the key concepts, this is where everything comes together and we can execute the project and see how it works. This is the environment file example. So as you know, in order to run the project, you need a .env file, and you have to add these 3 values to it: the OpenAI API key, Tavily API key, and LangChain API key. These 2 are free, and this is the one that allows you to interact with GPT models. And to get these API keys, you just need to simply sign into your profile for each framework, of course, and then you can easily find where you can generate a new API key for your project in case you don't already have them. So let's close everything and let's go through the notebooks folder. So in my notebooks folder, we have explore databases and test GPT models, 2 of the very common issues that occurred to many who try to execute my projects, where either they didn't have the right connection to their databases or they couldn't make the right API call to the GPT model. So I started to add these folders in my projects to allow you to make sure and verify those 2 before executing the projects or doing anything in those projects. These are the most common issues that may occur, so make sure that you have the right connection. And finally, the Python tip automatic docstring folder contains a notebook that shows you. First, let me explain the docstring side. So in a moment, I will explain why docstring plays a very important role in our tools and in our agents. So please feel free to check this out in case you want to use this project for your applications and you want to optimize the code or write it in a more modularized way. This might come in handy, and it might help you to have a more flexible code for your project. So let's continue and start designing our custom agent. And before that, I want to give you 2 key definitions here. So what do we mean by an LLM agent? An LLM agent is a large language model that has access to multiple tools. And what is a tool? A tool is a Python function that is converted into a JSON schema. So let's see how this works here. First, we start by loading some key libraries. I want the OS and .env in order to load my environment variables. I want openai, and I want Pydantic, inspect, and JSON to convert the Python function into a JSON schema. Next, let's define our function here. I have a function named ABC, and it gets two integers, and it computes this mathematical expression on those two integers. When you want to create a function and pass it to a large language model as a tool, there are a few points that you have to take into account. The first one is a very concise and informative description. So this is the docstring, and this is what I was talking about in the previous notebook in the Python tip. The docstring is what allows a GPT model to understand what tools to call based on your query. And then from your query, the GPT model is going to extract all the arguments that need to be passed to that specific function. So you need to also make it clear for GPT which argument is optional, which argument is required, and what are the type of those arguments that GPT needs to extract from the query. So here, as you can see, we have two integers, both are required. We have a description, and this is our simple function here. Let's test the function. So the ABC of 2 and 3 is -2. And this function converts our Python function into a JSON schema. What it does is this conversion. If I pass our ABC function to JSON schema, it is going to give me a dictionary. That dictionary is going to include some keys. One of them is name. The other one is the description of the function. The other one is the parameters. And as I mentioned in the parameters, we are going to pass all the information for the types and what are the parameters that are going to be passed to that function. And as you can see here again, it also mentions which one is required and which one is optional. So if I just simply ask a GPT model, calculate or compute ABC between 2 and 3, most probably it's going to give me the answer that, let's see what it says. To calculate ABC between 2 and 3, we need to know the formula or equation that involves A, B, and C. So as you can see, GPT is confused because this is just a function that I came up with. So GPT had no idea what I'm talking about. But in case I want to pass that function as a tool to my GPT model, this is how I can do it. I can wrap my tools into a list. It can be multiple tools, or it can contain multiple tools, or it can contain one tools in this case, and pass it to functions arguments in my GPT model. Then I'd set function call to auto, which means GPT will automatically decide which function to call, and also it's going to call a function for us. And the temperature is equal to 0. So if I ask the same question, compute ABC between 2 and 3, let's see what it gives us this time. So as you can see, finish reason here is function call. And if I print the details of what the model gave us, there was a function that was called. That function's name is ABC. The arguments are num1 and num2. And since the user asked compute ABC between 2 and 3, 2 and 3 were returned as values of our function arguments. And I also printed the type of the response of our GPT model. The type is a string. So I cannot just simply take GPT model's output and execute it in a Python environment. What I need to do first is to extract all the necessary information from the output to convert the arguments into a JSON structure, into a JSON schema, and then execute our Python function in the Python environment. So let's see how we can do it. The function name, I can simply get it like this, and the function arguments, I can get it like this. And as I mentioned, I'm going to convert it into a JSON format. So if I print here, function name is ABC, it's a string. Function arguments are num1 and num2, 2 and 3, and it is a dictionary, as it's indicated here. So right now, I can simply execute that function by passing the function arguments that the GPT gave me. So what is happening here is, imagine you have multiple tools and GPT can return different tools based on the user's query. A simple way to execute it in the backend of your chatbot is to do a name matching between the tools. So if GPT returned ABC, you can execute the ABC function by doing a name matching and then executing that function by passing the arguments that GPT returned in its output. So this name matching is just here to give you an idea of how we handle multiple tools in case we have passed them to our GPT model. So if I print the result, the answer is -2. So that is the full cycle of creating an LLM agent, passing tools to it, and then based on the user's query, getting the output and executing it in our environment. But using LangChain, things are a little bit easier. We can import a function named tool from LangChain's core.tools. And what this function does is it automatically converts our Python function into a JSON schema in the background. So we just add tool as a decorator to our function. And if I print abc.name, it's going to give me the name. If I print abc.description, it's going to give me the description. And it technically created this, but in the background, you don't see it like we see it here. But you can easily pass this to a GPT model as well. So how we can do that? We load our model through LangChain. We wrap our tools into a list, exactly as I did in our custom agent. And finally, we pass that list using bind tools, which is a LangChain built-in function. And now our LLM that we just connected to it using LangChain framework has access to the tool. So again, if I ask that model to compute ABC between 2 and 3, you can see that the model gives us the function name, which is ABC, the arguments, which are 2 and 3, and that's it. So we can simply create an agent using LangChain. And this is how we are going to do for designing our tools. And then we will pass it like this into our primary agent. And then we will start designing our graph. So let me start by showing you how we can design our tools for our primary agent. The first tool that I want to show you is Tavily Search, because this is the simplest tool that you can create, and it is technically a built-in class in LangChain's backend, so we can easily use this. Let me just quickly close it and open it again. Perfect. So, and I have to remove that. So you can easily call Tavily Search results from LangChain community.tools.Tavily Search. You have to load Tavily API key and set it as an environment variable. Then we can create a search tool. So that search tool can be created like this using Tavily Search results and by passing max results. So let's see what is happening here. Before executing the search tool, I want to show you that this search tool is exactly a tool. You can access its name. You can access to its description. So it is already a tool and we don't need to convert it. We don't need to add the decorator, and it's already built in inside LangChain's framework. So you can easily invoke that tool using what is a node in LangGraph. What it does is it performs a web search and it gives you the results based on the max results value that you passed when you created the tool. So that's it. That is Tavily Search tool, and that is how easy we can create it and we can add it to our system. Again, the main idea behind adding this to the system was I wanted to show you that you can add more tools, you can add more features to the system, and there is no limit to it. So just feel free to be creative, and if you need to expand the system, you can easily do it. So let's continue and let's see how we can design our RAG tool here. This is the notebook where I want to show you how we can design a RAG tool. And for designing a RAG tool, first I need to design a RAG pipeline. One of the key elements in both our RAG tools and SQL-Agent tools is the database that we want to interact with it. In the case of a RAG tool, it is going to be a vector database. And in case of the SQL-Agent tool, it's going to be a SQL database. I already mentioned in my previous videos, again, I'm going to suggest you to keep your data pipeline separate from your chatbot. And that is something that I've also done for this video. So let me first explain to you how we can prepare our vector database for our RAG tool. If you open the data folder, you can see there is a folder called unstructured docs. If you check it, you can find the stories.pdf and Swiss_FAQ.pdf. So the way that vector database preparation code for this project works is that it looks at folders and not files. So we are going to point it to a stories folder and Swiss airline policy folder. And it's going to check and see and find all the PDF files that are inside that folder and create a vector database from all of them. So remember, in case you want to change the project data and insert your own data, you can create a folder, copy paste all your PDF files and just point the class that is going to prepare the vector database to that specific folder. And where you can find that class, in source folder, you see a module named prepare vector database. If I open this module, we can see the class that prepares the vector database for us. I'm not going to go through all the details because this class is somehow identical to the one that we used in RAG GPT. I made some small adjustments, but if you have already watched the video, this class should look very familiar to you. So we start by loading the necessary libraries for the execution of our class. Our class receives the documentation directory. This is the directory of our raw documents. For instance, data, unstructured docs, stories. Again, point it to a folder. You pass the chunk size, the chunk overlap, the embedding model. The vector database directory is where we want to create our vector database. And the collection name is the collection name that we want to create in our vector database. First, it checks to see if the vector database directory already exists. If it exists, it doesn't execute the class. So keep it in mind. For instance, right now, since I have airline policy vector database and a stories vector database, this class will not be executed. I designed it like this because I wanted to give you a sense on the fact that you need to manage your databases properly. So whenever a change happens in your datasets, for instance, a new file is added to your folder, or one of the files is changed inside your raw folder, your whole pipeline should not be executed. You need to have a pipeline that just modifies and updates the vector database according to that small change. So that is an efficient way that you can design your data pipeline, especially if you are dealing with a large project. In this case, I'm not going to have all those small adjustments like updating a vector database or modifying a specific piece of that vector database, but I just put it there. So at least in case the vector database already exists, it won't execute the class for you. It won't execute actually this function for you. The first method in my class is called pathmaker. This method receives the folder name and the directory to that folder name, and it creates an absolute path and it returns the absolute path to us. So in case, for instance, I'm going to prepare the stories PDF file and create a vector database for it, it is going to give me an absolute path to this stories folder here. Then everything, all the data pipeline is going to be executed inside this method. First, I check whether the vector database directory exists. If it doesn't, I create one for it. Then we go through all the files that exist in our directory, the raw data. We load all the files, all the PDF files, and here I'm only loading the PDF files. And in case you want to load other type of files, for instance, text data, markdown files, etc., you need to modify the pipeline. I chunk all my data and I vectorize everything, and I create a vector database and store the vector database locally. So if we run this module, first it is going to set the environment variable. I need the OpenAI environment variable because I'm going to use the embedding model from OpenAI. I load the configs and I set the configs based on the vector database that I want to create. So here I want to create two vector databases, right? So I'm doing it manually right now. As you can see, this part is commented out, but in case you want to use this project for your applications, it is better to automate this process. So for now, let's leave it as it is. Here you can see the configs for the stories RAG. So it's going to load the PDF file, the stories PDF file, and prepare a vector database from that for us. We create an instance from our class, and then finally we execute the pipeline. Here on the bottom, I was just testing whether I can access that vector database or not, but it really doesn't matter, and we can even remove it here because when we are saving the vector database, I'm already printing the number of vectors that exist in that vector database. So let me run this module and show you how it works, at least on one of our datasets. So I need to remove stories vector database, and then I can open a terminal and run this module. So Python source prepare vector database. So let's see what happens here. First, it created the vector database. You also saw that the folder was added here. And here we go. So vector database is created and saved. Number of vectors in the vector database is 6. We have a 3-page PDF file in the stories.pdf, and we have 6 vectors in our vector database. So let me also show you the config files that I used for this purpose. So if you open configs, you can see 2 config files here. One is project config, which contains some general configs for our project, the memory directory, and the project name and the tracing that we want to use for connecting Langsmith to our project. And here we have tools config. So if you open this config, you can see that I prepared all the configs that would be needed for preparing the database and also the tool itself. So for instance, in Swiss Airline Policy RAG, we have the unstructured docs, we have the vector database directory, the directory that we want to create that vector database, the collection name that I want to create in my vector database. LLM and LLM temperature will be used when we are preparing the tool itself. So for now, for preparing the data, we just used these ones and the one on the bottom. So the embedding model that I'm going to use for this purpose, and in this case, I'm using text embedding 3 small from OpenAI. The chunk size is 500, chunk overlap is 100, and the number of retrieved content when we execute the RAG pipeline is going to be 2. So you can change this value in case you want to pass more data to your GPT model, more retrieved data to your GPT model. And you can also play around with the chunk size and the chunk overlap in case the performance of the model is not as good as you expect. And you can start play around with these configs and see what is the best configuration for your project. For the stories RAG, we have the same set of configs, but they are just adjusted for the stories RAG. So we just created our vector database here, and now we can start interacting with it. So that is what I want to show you in tools, RAG tool, step-by-step, RAG tool notebook. My goal in this notebook is to implement all the necessary steps for our RAG pipeline and then wrap them up into a function so we can convert it into a tool and pass it to our primary agent when we are designing our graph. So in this notebook, I will first show you all the steps, and then at the end of the notebook, I will show you how we can convert it into a function and turn it into a tool. So first, let's start by loading some libraries that we want to use. I need Chroma to load my vector database. I need OpenAI embeddings because I want to use the embedding model from OpenAI. And let's set the environment variable and some of the variables that we need for this notebook. First, I need the embedding model's name. I use text embedding 3 small to prepare the vector database, so I'm going to use the same model. The vector database directory is going to be data, airline policy vector database. That is the one that we want to interact with. And the number of retrieved content is set to 2. Feel free to change it if you wish, but I'm going to keep it as 2. And this is the number of retrieved content that we receive after performing the vector search on our vector database. So let's load our vector database. We have 22 vectors inside it. And this is a sample query. This is a question that a user might ask from our chatbot. So our system should be able to answer this question. Let's perform the vector search and let's see the results. So as you can see, 2 chunks were retrieved. One of them belongs to page 10 and the second one belongs to page 8. And these are the contents of those 2 chunks. In the next step, I want to prepare an input for my large language model. That input can contain the contents, the retrieved contents, the user's question, and also the chat history. But since I'm just showing all the steps here, I didn't have a chat history in this notebook, so the chat history is missing, but for now I want to prepare my user's message along with the retrieved content. And let's see how it's done. So I started by passing the content. These are the two chunks that were retrieved from our vector search. And this is our user's new question. What is the cancellation rule for a flight ticket at Swiss airline policy? So in the next step, I can just pass this prompt to a large language model along with a proper system role. So I'm just simply telling my model that you're going to receive this type of prompt. If you can find the answer, give it to us. And if you can, just let us know. Perfect. So let's print the model's output. Swiss Airlines allows passengers to cancel their flight based on the type of ticket purchased. So the model was able to provide us with the correct answer from the vector search. When I want to create that function and convert it into a tool, I don't want all these steps to be implemented inside it. All I want is to load the vector database, the proper vector database based on the user's question. I want to search the user's question on my vector database and retrieve the result. And I want my function to return the retrieved content to me. The reason behind that is my primary agent is going to play the role of this LLM that we saw here. So I don't want to integrate the LLM inside my function. All I want is to get the retrieved content and pass it to the primary agent in order to get the final answer. So this is the function that we can create for this task. As you can see, the name of the function is lookup Swiss airline policy. I have an informative description, search within the Swiss airline policy, and check whether certain options are permitted. Input should be a search query. I added the tool decorator to it, so now it can also be turned into a tool. And here we go. So I can print this information from that tool: the name, the arguments, and the description. So this tool is now ready to be passed to our primary agent. And our primary agent will have access to two RAG tools. One is going to be connected to the airline policy, and the second one is going to be connected to the stories vector database. And the model should be able to give us the right tool based on the user's question. We can also invoke the tool and see if it works properly. For instance, here, I'm just simply asking, can I cancel my ticket? My expectation is to receive the retrieved content from the vector search using this query here. So these are the two chunks that my tool returned from the vector search. So my tool works fine, and we can now pass it to a large language model. So we just saw how we can create a RAG tool and prepare it for our primary agent. In the next notebook, I want to go through the same process, but for our SQL agent. And we will design two SQL agent tools, and we will pass them to our primary agent. The first SQL agent is the exact replica of what we designed in the first video of this series. And for the second SQL agent, I'm going to modify the first SQL agent and just enable it to interact with large databases. So for our databases, I chose Chinook database as the large database in this video. And I also have a travel database. So I'm going to connect our first SQL agent to this travel database, and I'm going to connect the modified SQL agent to this Chinook database right here. Let's go through our first SQL agent and see how we can implement it and turn it into a tool for our primary agent. So first, we start by loading all these libraries. Then we set the environment variable and we choose our large language model. So as I mentioned, although LangChain's tutorials suggest us to use GPT-4o Mini, it doesn't work with, let me actually show you here quickly. It is not going to work with our SQL agent, and I assume that they are going to fix the problem soon. But for now, I'm going to use GPT 3.5 Turbo as a large language model in our SQL agent. But let's see the performance of GPT-4o Mini quickly, and then I will switch it back. Then let's load our database. And this is just an example query to make sure that we have access to the database. And this is the SQL agent chain that we designed in the first video. So this is the exact chain. nothing has changed, and I just copy pasted that chain in order to make it easier for you to follow. So let's see what happens if I use this chain with GPT-4 Omni. It seems that there was an error with the SQL query syntax. However, to answer your question, so we saw that the model failed to give us the answer. And in case I switch it with GPT 3.5 Turbo and create the chain again, we can see that this time the chain is able to give us the correct answer. There are 11 tables in the database, and these are the table names. So from now on, I'm going to use GPT 3.5 as the primary large language model in both our SQL agents. And this is how I'm going to prepare the code for the primary agent. So I have a class called Travel SQL Agent tool. What this class does is it just implements everything that we saw in the first part of this notebook, and it gives us the chain as an attribute of the class. So using this class, what I can do is to create a function. Let's call it query travel SQL database. Again, we add the tool decorator to our function, and we add the description. Query the Swiss Airline SQL database and access all the company's information. Input should be a search query. So this is an instance of the class. Now this agent has an attribute, which is our chain. So I can simply get the response to my question by invoking the chain. So agent.chain.invoke, and I pass the user's query to this function as well. So this is going to be the function and the tool that I'm going to pass to our primary agent as our first SQL agent chain. All right, so now let's modify our agent and interact with a large database. This is the notebook that I want to use for this purpose. SQL agent chain for large database. Let me close them. Perfect. So on the top, you can see the reference that I used for this strategy. And also I provided you with some instructions and explanation of what is happening inside this notebook. So I'm not going to go through them, but in case you are interested, please feel free to pause the video, or you can also go to the GitHub repository and check the instructions. First, let's talk about the problem that we want to solve in this notebook. Imagine you have a large SQL database with a lot of table names. And when we pass a user's question to our SQL agent, it fails to understand what table names to use to answer our question. So that is the problem that we want to solve. And for that, I want to show you 3 different strategies. The top 2 are the strategies that are proposed by LangChain, and you can also see the documentation using the same reference that I showed you on the top of the notebook. And this is a third strategy that I'm going to show you in the notebook, and I think it is a very good strategy, and I definitely recommend you to use it and test it and see if it can improve your system's performance. So the final goal is to take our SQL agent and add an extra step to it. That extra step is going to provide the list of table names that are relevant to the user's question to our SQL agent. And specifically, we want to pass that list to this large language model, because this large language model is in charge of generating the SQL query based on the user's question. And we want to improve its performance by providing it with the correct list of table names that it can use to generate the SQL query here. So let's go through each one of these strategies and see how they work. The first thing that you have probably noticed is that we are going to use a new large language model for this task. In the first strategy, we are going to pass the LLM, the user's question, a system role that contains the list of all the table names in our SQL database, and we are going to instruct it to extract the table names related to the user's question. So the LLM is going to do its best to give us the result. Although, in my opinion, unless you are interacting with a very famous SQL database, this strategy will most probably fail. For instance, in case your SQL database has table names that are not common outside of your corporation, there is no chance that the LLM can fully understand what tables are related to the user's question. So the first way that we can improve this system is by providing a more detailed instruction to the system role. For instance, if I give more information about my SQL database, and I also provide the large language model with a couple of examples and the queries that my users might ask, there is a great chance that we can improve the performance of our large language model and in case you are, for instance, dealing with a database with 10, 20, or 30 table names, in my opinion, this second strategy can be very effective. But in case you are dealing with a very large SQL database, and we cannot just integrate the list of the table names in our system role, one strategy is to simplify the task and break it into smaller tasks. So we are going to ask the large language model just to give us the category that our user question belongs to. For instance, in the Chinook database, I want to create two different categories, music and business. And I just simply ask the question, tell me the category that my user's question will fall into. So the LLM can tell me it is related to business, or it can say it is related to music, or both. Then I will get the LLM's result, and I will pass it to a Python custom function. So I have already implemented all the logic related to my SQL database in that custom function. No matter how many categories you have, you can easily implement the logic into a function, and you can execute that function. So this is the function that is going to give us the final answer, and we are going to pass it to our large language model here in the SQL agent. So these are the three strategies that we want to see in the notebook. And to design these three strategies, I'm going to use create extraction chain pydantic. This is a function from LangChain. And finally, to integrate any of these strategies into the SQL agent, we are going to use runnable pass-through class again from LangChain. So let's go through the code and see how we can implement those three strategies and how we can integrate them into our SQL agent. We'll start by loading the libraries that we want to use in this notebook. In the second cell, I'm setting first the environment variable for OpenAI, and I'm selecting the large language models that I want to use in my pipeline. So I have a SQL agent LLM for which I'm going to use GPT 3.5 Turbo. And I have a table extractor LLM. This is the one that I showed you in those three strategies. And for that, I want to use GPT-4o Mini. So one other way to improve the system performance is to play around with the GPT model itself. As you can see, GPT-4o Mini is the most cost-effective model, but it is not the most powerful model. Although it's going to do the job for us in this tutorial, and it's going to work very well. So I'm going to use it for this tutorial, but in case you want to improve the performance, you can definitely change the model here. In the third step, I'm loading the SQL database, and I just run a simple query on it just to make sure that I have the right access. In this cell, I'm going to create a table from pydantic from LangChain. We are going to pass this table to pydantic schemas in the function that I just mentioned in the slide. So this table represents a table in a SQL database, and this is just an object that we want to pass here. So let's run this class, and here I'm extracting the list of all the table names in my SQL database. In the first strategy, we want to pass this list inside the system role to our large language model. So this is the system role, return the names of all the SQL tables that might be relevant to the user's question. And the tables are, and this is the full list of our tables. Remember to include all potentially relevant tables, even if you are not sure that they are needed. And for that, we want to test with a sample question. The question, for instance, can be, what are all the genres of Alanis Morissette, I hope I'm pronouncing it correctly, songs. So the question that we are passing to the large language model is clearly about music, and we want to see how our large language model works. So it gave us 4 different tables: artist, genre, album, and track. But if you look closer to the list of the table names, you can see that there are more tables that can be relevant to that specific question. For instance, album, artist, genre, media type, playlist, playlist track, and track, all these table names can be relevant to our question, and our large language model failed to give us the full list. So in the next step, I'm going to improve the system role. You will receive a question. If the question is about music, return all these tables. And these are the list of the tables that I'm expecting to get in the output of my large language model. And if the question is about business, return these tables. And finally, if you're unsure, return the full list of all available tables for both music and business categories. So let's test this system role and see how it works. Perfect. So as you can see, it successfully returned the full list corresponding to our question. This strategy worked very well for our scenario. However, let's also go through the third strategy, which is the one that I'd recommend you to use in case you are dealing with a very large SQL database. And this is the one that LangChain proposed in their documentation. And at the end of this notebook, we are going to integrate this strategy into our SQL agent. So the system role says, return the names of the SQL tables that are relevant to the user's question. The tables are music and business. So these are actually our categories. And really, there is no difference if I tell the model to return the category or the table name. The model would eventually treat both of these system roles the same. And here, my main goal is to simplify the task for my model and just ask it to give me the category for my question. So let's create the category chain here. And let's see the results. So perfect. The model correctly understood that our question is related to the music category. In the next step, I want to take LLM's output and feed it to a Python function. So as I mentioned, I have already implemented the logic in my Python function, and this logic represents what I want to achieve by interacting with my SQL database. So I have a tables list that is empty, and then I'm going to loop over the categories that were returned from the model's response. In case the category is music, I'm going to return this list. In case the category is business, I'm going to return this list. And in case both of the categories were mentioned in my large language model's output, I'm going to include all the table names and return the full list in this function. The way that we can create a chain to integrate it into our SQL agent is using this method here. So we have a table chain that contains our category chain, which is the one that we just executed here. The result of the category chain is going to be passed to our Python function, which is the function that we just defined here. And if I invoke this table chain, I'm going to receive all the table names that are relevant to the question that I passed my system. So this is, again, working perfectly with our scenario. And this scenario is more scalable in case you are dealing with bigger SQL databases. So let's continue and let's integrate what we just created here, the table chain, into our SQL agent. So here in the first step, I'm creating a SQL agent using this function, which receives the large language model and the database that I want to interact with. In the next step, I need to provide an input for my table chain. What is the input for my table chain? It is the user's question. So I will create the input for my chain, for my table chain. And finally, I combine these two pieces together. So on one hand, I have a query chain, which is my SQL agent. And on the other hand, I have the table chain, which is the chain that we just created together. So this chain is going to pass the list of the table names to our SQL agent. So now I have a full chain ready and we can test it. One last note before we pass the question to our SQL agent. So the SQL agent that I designed in this notebook is a simpler version of what we designed in the previous notebook right here. So in the third notebook that I didn't cover in this video, I've showed you how we can prepare this agent and how we can interact with a database. So I didn't go through it because this is something, again, that I've covered in the first video of this series. And this is technically a simpler version of what we already covered in this notebook. So this agent gives me the query that I can use on my SQL database in order to get the answer for my question. So if I pass my question to this full chain, in return, it's going to give me the query for this question. Here is the query. And one last step is to run that query on our database. And here is the result. So in this notebook, up to this point, we saw how we can design an agent to interact with a large database. One last step is to prepare a tool from this SQL agent. So this is the class that I used in my project in the source folder. And this class implements all the steps that we just went through in this notebook. And finally, I can just simply create a function named query Chinook SQL database. Again, using a description for that function and also adding the decorator tool to it, we can create a tool to pass it to our primary agent. So up to this point, we saw how we can prepare the SQL tools. We saw how we can prepare the RAG tools. And we also saw how we can prepare the Tavily tool. Now let's go through the last step and use everything that we have seen so far in the notebooks and start designing our full graph. So this is the notebook called Full Graph. And this is where I want to show you how we can create the tools and start designing our full graph using LangChain and LangGraph. So I just modified the notebook to make the content more understandable. Let's begin and let's go through it together. So here we want to design the full graph using 3 tools: search tool, RAG tool, and a SQL-Agent tool. So here I didn't want to overcomplicate things and prepare 5 tools and pass them to the primary agent. And mainly I want to focus on the graph design in this notebook. So if you understand the full process, reducing or increasing the number of tools is a very easy task, and you can easily adjust it based on your needs. So let's begin by setting up our environment variables here. So these are the libraries that I need. And here I'm setting the environment variable for OpenAI and Tavily search. The first step to prepare the graph is to initialize the tools and bind them to our primary agent. So let's prepare the tools first. The first one is the RAG tool, and let's also test it. So here, the output is the retrieved content from the search result using this question. And now let's prepare the search tool. My maximum result is 2 here. Let's also test this tool. And here we go. So we have 2 search results for this question. And here I'm going to prepare the SQL-Agent tool. So my SQL-Agent is going to interact with the Travel SQL database. And this is the first tool that we saw in the notebooks. So let's also prepare that SQL-Agent tool, and let's test this one as well. So how many tables do I have in the database? You have 11 tables, and these are the names of the tables. Perfect. So here I just wrap them up into a list and bind them to my primary agent. So my primary agent is going to be GPT-4o mini with temperature equal to 0. So up to this point, we prepared the tools and we prepared the primary agent that now has access to all our 3 tools in this notebook. In the next step, I want to initialize the graph state. So in my state, I want to keep it simple. I just want to have a list, and that list is going to store all the chat history and all the steps that happen in my graph for each query. So this is my class state, and using state graph, I'm creating a graph builder. So using this graph builder, we can now start adding nodes and edges and start designing our graph. The first node that I want to define and add to my graph is the primary agent node. So this is going to be the first node that is going to be executed after each user's query is passed to my system, or let's say to my graph. So I create a function called Chatbot, and that function is going to contain a dictionary. The key is messages, and the value is my primary agent getting invoked with the last message in my state list, the one that we just created above. So that was our first node. The second node is a node that executes the functions that my primary agent calls. So let's say my primary agent, based on the user question, gives us a function. So I showed you in this notebook here how we can execute that function manually. So this class right here is just a modularized version of executing those functions inside our graph. So this class is going to check the last message in our state in case the last message is calling for a function. And as you can see right here, I'm just checking if the message has a tool call. So in case a tool is called, this class is going to find the corresponding tool, it's going to execute it, and it's going to give us the answer of the execution of that tool. So I create a class instance using basic tool node, and I add it as a node to my graph. So far, we added 2 nodes. First was the primary agent, and second was this tool node, which is responsible for executing the tools. In the next step, we want to create an edge. Edge is the connection between the first node and the second node. So there are multiple ways that you can do it. This is how I did it initially, and in the backend of the project in our source folder, you can see this code right here. But recently I checked LangChain's documentation and I noticed that they modified the way that they are creating this edge. So the way that they are now creating the edge is like this. And if you check these two cells, you will see that they are exactly identical. So for instance, this end here that I'm calling in my output, if you go into the end that they defined in their backend, you see that they are equal. So technically these two cells are exactly identical, but just the syntaxes and the way that they define it is a little bit different. So this cell is how I designed the project in the source folder, and this cell is the way that I want to show you in this notebook, so you understand that there is no difference between them. So first, I'm going to create an edge, and then I'm going to also set the start point for my graph. The start point is my primary agent, which we defined it above as Chatbot. Perfect. The last step is to just simply compile the graph and start interacting with it. So let's also compile it here. And while I'm compiling it, I also added a memory to it. So in case you want to trace the chat history, or in case you want to give your user a smooth user experience while they are chatting with the chatbot, you can simply add a memory so the chatbot remembers the user's previous Q&As and it gives them a very smooth conversation. So let's also plot our graph. Perfect. So we have the start. It is going to be connected to our chatbot, which is our primary agent. Our primary agent is going to be connected to our tool node. This node is going to execute any function that our primary agent calls, and it's going to give back the result. In case the primary agent decides that another function needs to be executed, again, it is going to get connected to the tool node, and again, it's going to receive the answer for the second function. And in case our primary agent decides that this is all the information that I need to give my user the final result, it is going to just pass the result to the user and show the final answer to them. So this cell, you can just skip it. This is where I was saving this image to show it to you. And here we go. So we can finally start and interact with our graph. As I mentioned, the first thing that we need to set is the thread ID. And this is somehow a way that you can distinguish different chat sessions for your users. So I'm just going to keep it as one here, but definitely in case you decide to use this project for your applications, you need to modify this part. Let's start by a simple query, a query that does not require any tool. So hi there, my name is Farzad. And there are two ways that you can interact with the chatbot using LangChain. The first one is to print everything that happens inside the graph, which is this one, or you can simply print the last and final result from the graph, which is just simply the primary agent's output. So in the project, I'm going to use this one because I also want to print everything that happens in my graph in the terminal and observe what is going on. But in case you have tested the project and it works well and you just want to simplify things, you can also use this second approach here. So let's ask another question, and this time let's trigger the RAG tool in our graph. So the question is, can I cancel my ticket 10 hours before the flight? This is the user's question. A tool was called, which is called lookup policy. Then that tool was executed using our second node in the graph. And this is the model's final response. You can cancel your ticket with Swiss Airlines, but the ability to receive a refund, etc. So as you can see, these are all the steps that happened in our graph after passing that query to it. The third question is going to trigger the search tool inside our graph. So actually it's not right now anymore, but let's leave it as it is. So right now, Harris versus Trump presidential debate is being broadcasted. I want the YouTube link to this debate. So this is how our graph responded to that query. This is the user's query. This is the tool that was called Tavily search result. And you can see the search result here. And you can see the model's output. You can watch the debate of Harris versus Trump using either of these two links. So if I print the full event, everything that happened so far in my graph, you can see the full list of messages that were exchanged between the user and also different nodes of the graph. So this is the first message that was passed to that graph. And here also the same message was passed because I wanted to show you two different ways that you can interact with the graph. And these are the follow-up messages that we wanted to see how our graph can trigger different tools and can execute different tools based on the user's query. So in this notebook, we just saw how we can define and design our graph from the start to the end. So in the next step, I want to walk you through the project that I designed in the source folder. All right, so let's go through the project together. So this module is the one that we have already used it in this video, and I'm going to skip it. But we have a module named app.py, and this is the top level module that is going to work and interact with the backend. So this is our user interface. And as you can see, I've used Gradio to design it. And from line 6 to line 40 is the part that I'm designing the user interface. And these are the functions that send the user's query to our backend. So as you can see, these functions are sending the user's query to a class called Chatbot, and that class has a method that is called respond, and we are going to interact with that method. So let's go to Chatbot folder. So this is where I'm interacting with. I have Chatbot backend, I have the load config, and I have memory.py. So Chatbot backend contains a class called Chatbot, and this is the class that I'm interacting with from my user interface. And specifically to this function right here, respond, that receives the user's query from the user interface. It then gives that query to the graph, and it receives the final answer from the primary agent of our graph. So this is how I'm passing the user's query to the graph. And finally, it sends back the response, the final response, to the UI so we can show it to the user. So this is the backend of our chatbot. As you can see here, I have already created my graph. I already have set the thread ID, and I'm passing that graph to this function right here. I have load config in this folder that loads the general config that I need for my project. And that contains two different parts. First, this is how I'm going to connect my project to Langsmith. I'm going to set the API key for LangChain. I'm going to set the tracing equal to true. Let me just quickly show it to you. This is the tracing equal to true. And I'm going to also give it a project name. So let me quickly show it to you right like this. So this is my project name. This is tracing equal to true. And it also sets my LangChain API key as the environment variable. I also have a memory directory that is going to create this folder right here. So in this folder, I'm going to have a CSV file for each date, and it's going to store all the Q&As that happens between the user and the chatbot. So let me show it to you. This is the folder called memory, and these are different CSV files for different dates. And if I open this last one, for instance, let me quickly, perfect. So if I zoom in, you will see the thread ID, which is equal to 1 in my project, the timestamps for each Q&A, the user's query, and the response. And these are not empty, actually. If I double click on them, you can see the query in each one of these cells. So that is the memory, and that is how I'm storing it. Again, having Langsmith alongside the local memory is not going to be a good practice. Eventually, you can choose one of these two strategies. If you're planning to have a custom dashboard, it is better to elaborate and develop the memory side. Or in case you are going to use Langsmith, you can easily remove the part for the local memory, and you can continue and use Langsmith. So this is the load config module. This is the chatbot end, and we also have the memory here, which is going to receive the user's query along with the model's response, and it's going to store it in each one of those CSV files. So this is the chatbot folder. We also have agent graph folder and utils folder. So utils folder contains some general utilities that I'm going to use in this project. For instance, this is how I'm going to collect users' feedback, the thumbs up or thumbs down based on the response that they receive. And also app utils contain a simple function that creates a directory for me. So let's go through the agent graph. This is where I'm designing all the tools. And also this is where I'm designing the graph using those tools and the configurations that I have in tools_config file. So if I close this one and close this one, perfect. As you can see, I have tool Chinook SQL-Agent, tool lookup policy RAG, tool stories RAG. And so these modules that start with tool name, these are the ones in which I'm designing my tools, the 5 tools that I'm going to pass to my primary agent. For instance, if I open one of them, this is the Chinook SQL-Agent, the SQL-Agent that is designed to work with a large SQL database. And you can see this is very similar to what we designed in the notebook. Actually, it's identical, but it's just designed in a modular format in this module. So these are the tools modules. Then I have load tools config. In this module, I'm going to load everything that I have here in this config file. Then I'm going to distribute them over these modules, and I'm going to just collect whatever I need from this class in each one of my modules. So this is the load config. Then I have build agent graph. This is the class that builds the graph for me using the modules and using the GPT models that I have set in my config file. And I have agent backend. So this is the module that contains some of the necessary classes and functions that we want to use in the agent. For instance, here I have defined the state class. I also have basic tool node, and this is the one that I showed you that is responsible for executing the tools after the model calls one of them. I have route tools. This is the one that creates the edges in our graph. And this is the one that I showed you, but I didn't execute it in the notebook. So this is approach number 1 that I showed you in the notebook, but I didn't execute it there. I also have plot agent schema. So when we are executing the project in the terminal, I am also plotting the agent schema just to make sure that the schema is correct and I'm on the right track. So this is the agent graph. We went through chatbot folder and we also went through the utils folder. So that summarizes our project. Now let's first quickly test it, and then I want to show you how you can remove or add new tools to our project. So in order to run it, open the terminal, Python source app.py. So it's going to execute this module right here, which gives us this link for our chatbot. Perfect. So this is our chatbot. I have already opened Langsmith. As you can see, there are no runs for the past 7 days, but as soon as we start interacting with the chatbot, we can see the most recent runs here. So let me start by the first question, which is from the stories vector database. So that vector database in general is not a complicated database. So let's just ask who is Fred. Fred is another fictional character in our database, and let's see if our graph can find it out. So Fred is a small red fish who lives, so that is correct. Fred is a small red fish, and our chatbot correctly pointed out to the right character. Let's ask another question from our airline policy. Again, this is another RAG tool. Can I cancel my ticket 10 hours before the flight? The answer is you can cancel your ticket without penalty only if you do so. That is correct. Again, the chatbot was able to point to the right vector database and give us the right answer. Is there any flight available on the travel database that goes from CDG to BSL? So this question is referring to our travel SQL database. And what I'm trying to understand is whether our agent, our SQL agent for that database, is able to find out available flights for these two airports. And this is somehow a complicated question for our system. So let's see how our agent would respond to that. Yes, there are available flights from CDG to BSL. That is correct. Specifically, there are 5 flights with flight number LX something. If you need more details about the schedule, departure, and arrival times, please let me know. Let's just see if the system would be able to give us more information. I need more information. Thanks. Yes, I need more information, more details about the schedule, departure, and arrival time. So our SQL agent was actually able to give us the details for those 5 flights. So let's ask a question from the Chinook database. So this is our large SQL database. And the question is, list the total sales per country. Which country's customers spend the most? So my expectation from this agent is to give me the answer for 2 different questions. First, I wanted to list total sales per country, and then I wanted to understand which one of those countries spend the most there. So USA, $523 up to Germany, and the country whose customers spend the most is USA. That is correct. So let's ask another question now. What are all the genres of, again, the same question that we saw in the notebook? Is primary rock. If you need more information or details, feel free to ask. So let me ask a follow-up question. Give me a couple of, actually, her albums names. If you'd like more information or additional album names, please let me know. I need more album names. I just want to see how far our agent can go. And as you can see, I'm asking follow-up questions. So the system should be able to leverage the memory that we designed for it. It appears the only album listed is this one. So let me ask one final question. Give me the link to some websites for LangGraph tutorial. And this is going to trigger our search tool agent. And my expectation is that our system is able to give me 2 links. So first one is DataCamp LangGraph tutorial, and the second one is LangChain LangGraph tutorials. Let's open this one. This is perfect. This is exactly LangChain's documentation, and this is the website that I used to get the knowledge to design that system that we just saw in the video. Let's also see what happened to our Langsmith website. So as you can see, right now it shows me that there were actually some queries in the past, I assume, yes, last 7 days. And these are the queries that we just asked from the system. I strongly recommend you to also observe your system and check the performance. And for instance, just right now, by having a very general look, I noticed that my system right now is slower than usual. So that is how useful Langsmith can be. And I showed you how you can easily integrate it into your project. So it is a very useful tool to have next to your project. Now, there is only one last thing that I want to show you, which is how to add or remove an agent, let's say a tool, to this system. So in order to remove one of these tools that I added to this system, it is very easy. In case you go into this module right here, build full graph, if you scroll up, you will see 2 lists that exist in this module. One of them is called tools, and the other one is, again, it's called tools, but it is in basic tool node class. So if you want to remove any of the tools that I designed for this project, you can easily remove them from these 2 parts. So you have to remove that specific tool from both these 2 lists. In case you want to add a tool to this system, well, of course, I'd first recommend you to add all the necessary information for that tool here. For instance, let's call it new RAG. And let's say that you have a new folder called new folder. and you want to have new vector database, etc. So set all the configurations for that new tool in this config file. In the next step, let me remove it here. In the next step, open load tools config. This is the module that I told you it's going to read all the configurations from our YAML files, and then it's going to distribute them in our project. And load all those configurations that you just added here. In the next step, open a new module. Let's call it tool new rag.py. In this module, for instance, you can use one of the previous RAG tools. Let me just copy paste it here. You just modify the name based on your new tool. For instance, here, I'm going to call it new RAG tool. Then here, I'm going to call it lookup new data. I'm going to bring this one here. And for these configurations, point them to the right configuration that you just added here, and you loaded them in load tools config. As you can see, I have already access to those configurations here. So this tools config can easily give you the access to all the configurations that you just added in your YAML file. In the next step, when I have it, let me actually keep this module here. So in the next step, open build full graph, add your new tool here. So from agent graph dot tool new rag, import lookup new data. So this is the tool that we created in that new module. And then simply add it to the list of your tools in both tools right here, and also add it to the list for basic tool nodes. So this is how easily you can add or remove a tool from this project. But for now, I'm going to just remove this from here because this is not pointing to any vector database. And I'm also going to remove this from here just to make sure that the project is functional and you can run it without any issue. So that was it for this video. In case you have any questions, please let me know in the comment section, and I hope to see you in the next one.